All right, before we get into solving exponential equations and logarithmic equations, I'm going to show you one more thing that helps quite a lot with logarithms. And I guess I'll just get right to it. So let's say we have a log with a base 4 of 293.68. So some weird thing that we're not going to be able to do in our heads. But also, several calculators, most calculators, just don't have the ability to do log base 4. Right? There are two buttons that you'll often see on your calculator, and if you're lucky, one of the buttons will have log with a little square here, meaning you're allowed to put in whatever base you want. Well, for you, go ahead and put log, put a base 4 of 293.68 and get your answer. Great. This video is not for you because you have a calculator that does it. But I mean, it's always good to know, just in case for the future, that there is a way to do it even if you don't have that. Right, so the other calculators that don't have that will just have a button that says log and another button that says, I say ln, there are different ways of pronouncing it. This is the natural logarithm, this second one, and this is the logarithm base 10. Right, so if you don't see anything at the bottom, then that means it's base 10. If you see ln instead of log, well, that's a base of e, which is approximately 2.71828. It's like pi. It's an irrational number. This is called the natural logarithm. This one's called log base 10. All right, so let's say we do have log base 4. Well, let's just, let's figure out how could we do that. Well, let x equal log base 4 of 293.68. Okay, well, what we do know, what we've practiced quite a lot, is that we can also say that 4 to the power of x is equal to 293.68. This is the exact same equation, but in the exponential form. We also know that we're allowed to, it'll keep the equation the same if we take the log of any base, so let's just take the log base 10 of both sides. And that equation will still stand 0.68. Now we could have also done the natural logarithm if we wanted to. We could do it at any base. You could take the log of both sides and you will keep the equality. We also know by the power rule that ln of 4 to the power of x is just equal to x times ln of 4. Or we could have done the same thing at the top, ln of 293.68. Or up here, we could have said that that is x times the log of 4, which equals log 3.68. Either way, right? Because if you have, this is the power rule, if you have a log of something to the power of something, that thing can come back down, right? Now we divide both sides by the same thing. Here you would divide both sides by ln of 4. Here you could divide by log of 4. Just to say, I could have done any base I wanted, but these are the two that my calculator understands really, really well. Right? So x is equal to, well, we already know that x originally was equal to the log of 293.68 to the base 4. But we also now know that the x is equal to the ln of 293.68 divided by the ln of 4, or x is equal to the log of 293.68 over the log of 4. Those are base 10. And we could have used any base there. I could say log of any base 293.68 divided by the log of any base of 4. So as a general rule, if you have any log with a base that you don't like, so let's say log base a of b is just going to be equal to the log of any base, so let's say c of b, divided by the log of any of that same base of a. These are going to be equal. Okay? How is that useful? Well, if at any time you're doing a problem and you have the log base, let's say 4 of 293.68, and you don't have a calculator that does it, well, you just simply do the log of whatever base your calculator does have of the top one. Take the answer, divide it by the log of what that same base that your calculator does have of the bottom one, and you are good to go.